Hi there, FAHA students. I'm Zackary Dunivin. I'm the TA for uh, the Foundations and Applications of Humanities Analytics course on Complexity Explorer. And I'm going to talk to you in a two-part series about how to do some of your own analytics, how to get started doing some of this work on your own. So I'm recording this in the spring session of 2022. So I'm going to walk you through a brief slideshow talking about the kind of different areas that I think you need to be aware of to start doing this work on your own. This slideshow will be available to you. It has some helpful links to get you started on setting up your own little laboratory or workshop so that you can program, write scripts, and perform analyses or run a simulation or process data in ways that are really difficult or impossible to do without being able to control the computer really directly to tell it exactly what you want it to do instead of using other people's software. So here's an overview of what I'm going to be talking about, and basically this is all to get you so that you can write and run code on your home computer. So I'm going to talk about picking a language. There are many different programming languages. They have different strengths and weaknesses. I'm going to be doing all of this in Python, which is really kind of the standard tool for people that are doing basic or broad scientific programming. Python has a really low barrier to entry. You can write things very quickly. So that I'm going to be talking mostly about Python. And then you're going to have to set up some tools so that you can work in that language. And I'm going to be talking about shell, installing the language on your computer. Most programming languages that you might be using, well, some of them will come pre-installed on your computer, but even if they're pre-installed, they may not be exactly the configuration that you need. And then I'm going to be talking about the coding environment where you're actually going to do the programming and run your scripts. And then I'm going to, very briefly talk about writing and running code on your computer once you've got all of that set up. If you embark on this, it's going to be a lot of work. It's a lot of work to learn how to script. And it's a lot of work just to get things set up so that you can run code on your computer. So, if you're expecting with very little experience, if you're expecting to do this, or if you're intending to do this, I should say, you need to expect that you're going to be spending somewhere between 10 and 20 hours, I think, just getting things to work on your computer. And then after this, in part two, I'm going to walk you through a Python notebook that I have to show you an example of an analysis and kind of explain the different parts of the analysis and give you a very brief overview of what code looks like and how we run it so that you can start learning on your own. Okay, so the first thing we need to do is we need to pick the language that we're working in. Like I said, there are many different languages. They're good at different things, but people who are doing the kind of work that we're talking about tend to use Python. Why do they use Python? Well, it's really easy to learn it's very easy to read. It's really a pleasure to work with, I feel, especially compared to some other languages. It's a scripting language, which means that it's kind of a Swiss Army knife. You can really, anything that you want to do, you can do in Python. But it's also, that means that it's not specialized to do any particular thing. And so certain languages will be, pretty much, Python is not best in anything except being good at everything. It's best at being good at everything, I would say. So you can do data processing, you can access APIs so that you can upload or download information from the internet. You can run simulations, you can do machine learning, you can do statistics, you can do graphics. It really does everything. But it's one of the costs is that it's slow compared to a language like Java or C. And like I said, it's less specialized. So it can do all these things, but actually it may be best for data processing, but it's not going to be the best necessarily to certainly to do statistics or to do linear algebra, to do a lot of kind of, if you're writing complicated algorithms, Python may not be the best choice. If you're building applications for other people to use, Python is definitely not the best choice. But for the things that we're talking about in this course, Python really is the best programming language for this. And one of the reasons is that there are just lots of libraries and resources for learning Python, tutorials, and libraries are these, kind of, it's people who have written code and often written it very nicely and made it very easy to use, and then package it up and put it on the internet so that we can all use it in a way that is standardized. It's not, just copying and pasting. It's installing a set of scripts that you can then load into your Python environment and reuse somebody else's code. So here I have a set of resources for learning. There are books and courses. I recommend Learn Python the Hard Way. It's how I learned to code. I spent about 2 weeks spending, 6 to 8 hours a day. And by the end of that period, or really even midway through that period, I was programming on my own. I was capable of doing a lot of the stuff that I'm going to show you in the tutorial. Official manuals are a really great place to learn exactly how to use certain pieces of code, how syntax works. There are lots of tutorials. So if you want to do something, the very first thing that you should do, if it's not something that you've done before, is just go to Google, type in, I want to do this, and immediately you will find tutorials, some of which are very, very good and will give you a good idea of how tools work or what tools are available or how to set up a workflow. There are lots of people that spend their time making resources so that people like you and I can benefit from their knowledge. And then kind of, I would say, maybe the most important tool to programming today is Stack Overflow, which is an internet forum where people post questions saying, I want to do this, what's the best way to do it? Or I'm running into this bug, and you will get really good responses. It's really an incredible community. It makes programming so much faster. It makes it so you don't really have to learn the language, and you don't have to make everything from scratch. You can go and learn from the community. Okay, so when we are writing our scripts, we're going to do that in some kind of editor. And there's really two kinds of editors. There's the basic editor, which is a text editor. The most basic would be something like Notepad or I don't know what they call it in Mac OS, but text edit. It's just a place that I can go to write down a script and save it. And there are, though, text editors that are specifically designed for writing code. And I have 3 of them listed here: Sublime Text, which is the one that I recommend, Notepad++, and Text Wrangler. Sublime Text is really an amazing piece of software, and you can download it for free. And if you end up liking it, you can send them some money. So the features that good text editors will give you are syntax highlighting, which makes code easier to read and it makes it easier to find bugs. Smart saving, so that you don't lose your work, and some productivity tools, which Sublime Text has many, many extensions. Just like there's a community for Python writing libraries, there is a community for Sublime Text writing extensions, like basically the browser extensions like you would see in Chrome or Firefox. The other kind of text editor is an interactive development environment, an IDE. It gives you all the features that the text editors have, but it also allows you to run individual lines or blocks of code. When you run those pieces of code, it will store the current state of the code in memory, which means that if you are testing something that takes a long time to run, and you have a set of code that takes a long time to run but runs well, you run it once, and then you can test what happens after that without having to rerun that thing that takes a long time over and over and over. So an example of something that would take a really long time would be loading data into memory, or processing data if you're processing a lot of data, or you're processing it in a way that is computationally intensive. And then it also will have tools for debugging, which I'm not going to talk about. There are many free development environments. The one that I like is VS Code. I'm going to be showing you the demo in VS Code. That's Visual Studio Code. Eclipse is another free one that people really like. There are Python specific ones. There are lots of language specific ones. R has a fantastic development environment called RStudio that is really, it's just an awesome piece of software. I would never write R in any other environment. I feel less attached to Python development environments. Mostly I write stuff in Sublime Text and just run it from the terminal. Okay, so it's really important when you are a coder, when you are a scripter, to be able to interact with the computer in ways that most ordinary users don't anymore. And this is using the shell. So this is that black screen with the green writing, or with white writing, where you're kind of directly telling the operating system that you want it to do a particular thing, like open a file, or go to a particular location, or tell you, what files are in that location. But usually, basically what you're doing is, instead of having the graphical user interface, the GUI, clicking on things and typing on things in there, you are just directly telling the computer, run this particular program on this particular input. So in Linux and Mac OS, these are Unix and Unix-like systems. Mac OS actually is Unix and Linux is Unix-like. We're going to be using either Bash or Z shell. Mac OS just recently switched to Z shell as the standard shell. You can use either Bash or Z shell in Linux or Mac OS. In Windows, Windows has its own system called PowerShell, which frankly I think is really ugly and clunky and a pain in the butt to work with, compared to Bash, though Bash has things that are goofy about it too. And this, this really is what computing was prior to the development of graphical operating systems prior to Windows and Mac, basically. And we can still work this way, and many people do. Millions of people do every day. And yeah, and it is essential to be able to work in the shell if you're going to be running scripts and installing software that you need to be writing your own code. It's just it's a skill that you can't get away with not knowing. Okay, so I said that we were going to be using Python. The easiest way to work with Python is with Conda. Any computer that you are using, any operating system is going to have Python installed on it already. The current version of Python is something like 3.10. At this point, Python 2 is largely deprecated. You're not going to be writing Python 2. It's going to be rare that you encounter Python 2 code. Probably any computer that you're using is going to have Python 3 on it. And you can just use that version of Python, but Conda makes it much easier to work with Python and make sure that you have the right packages installed that are going to be compatible for your system. It just makes everything easier. And it is available for Windows, Mac, and Linux. And I highly recommend that you get started with Python. Later on in this presentation, with Conda. Later on in this presentation, there is going to be a link to a tutorial that will take you through a lot of the steps needed to get started with Conda, and in particular, Jupyter Notebooks, which I'm going to talk about in a little bit. Right now, in fact. So Jupyter Notebooks are they are a way of storing and running and storing code that makes it really easy to share your analysis with other people. It has both a way to mark up your code with text to explain what you're doing beyond just writing comments. It has the code itself, and then you can save the output of your code so that you can do a whole project if you want, run it, save it, and then somebody can open it up and see exactly what you did and what the results are. They're really good as teaching tools. They're less good, I think, as science tools. It functions like a mini development environment. So there are extensions for it. There's syntax highlighting. You run blocks of code. The results get stored in memory. You will launch it from the terminal by typing in Jupyter Notebook when you have Jupyter installed. And then you can run it in either a browser like Chrome or Firefox, or you can use a development environment like VS Code and run your Jupyter environment inside the development environment, which is what I'm going to be doing today. If you have Conda installed, Conda will manage your Jupyter installation. And that link will take you to the tutorial that will help you install Conda and then install Jupyter with Conda. So how do we program? Even when you're a novice, but you have started, you've done the Learn Python the Hard Way book, or you've done a course on the internet, you're still kind of, faking it till you make it. Like you're not going to be fluent in a language now with the internet doesn't mean the same thing as fluency did before. You don't need to know all aspects of the language because there's just so many good tools that will allow you to get by without knowing 100% of the language. So, I would say the most important skill in programming, and in particular learning to program, is searching the internet for your particular problem and finding a good solution to that problem. So you will build the skill of describing the particular problem that you're encountering in programming, so that you can find good solutions. Like I said, Stack Overflow is really the best place for finding earlier, if you have a problem, someone else probably had it first, and they probably asked it on Stack Overflow. So these can be syntax problems, these can be algorithms, like what is the most efficient way to write this code. It can be aesthetics. I'm trying to make a plot look a particular way. Can somebody help me? Then also referring to programming manuals. So both languages and packages will have official documentation, which if it's widely used, will tell you very clearly how to use different components of the language or package. And then, like I said, there's lots of tutorials available on the internet to learn how to do all sorts of things. And often you can just copy and paste someone else's code, and that will give you enough to get started working on your own problem. I've been doing this for 7 years. I program almost every day. I still do all of these things. And I consider myself a very good programmer. Okay, now I'm going to talk about running code from the shell. So this is like you've written some code and you want to run it. So you're going to open the terminal if you're on Linux or Mac, command prompt if you're on Windows. You're going to navigate to the folder where you've saved your script. In Bash or Z shell, you're going to say chdir, which is change directory, and then you put your path there. In PowerShell, you say set location, and then you write your path. Then you run the script and you look at the output. And so this has this line here has two components. The first is saying, I want you to run the command Python3, which opens something up in Python, opens up your input in Python. So your input is the name of your script. Whenever you run something for the first time, you're going to have errors. And Python will tell you very clearly, I'm running into this problem at this location. So you go to that line, you fix the error, you run it again, and then you'll find a new error. Usually, you're going to have a syntax error. That's the most common thing you're going to run into, is just you forgot to put a colon or a parenthesis or a quotation mark, or you did a typo, misspelled the name of a variable. But sometimes you will get errors in Python that basically say, you think that this thing is this kind of thing, but it's actually this other kind of thing, and I can't do what you are asking me to do to this kind of thing. And that really is, that's the game. I mean, you just do that over and over until you get the output that you want to see. In an IDE, it's really the same. You're going to open the script in the IDE like it's a text editor. You press run. There's going to be a little terminal in the development environment that is going to give you the same output that you would get in terminal or command prompt. But the IDE is going to hold your process. And by that, I mean, once you've run the code, it's going to store the current state of the system in memory, so that you don't have to run it again. You can just work on the parts that are broken. So that's all I have for you in this first part, but I encourage you to post in the forum if you're running into problems, and in particular, just go to the internet and you will find people that have had exactly the same problem on exactly your system, and they will provide the solution to you. Hello again, FAHA students. This is part 2 of the demonstration on doing text analysis with Python. I am now in Visual Studio Code, VS Code, the development environment, and we are looking at a Python notebook. And this notebook is something that I put together in talking with Simon and David, trying to look at the discourse around single mothers or single motherhood in the New York Times, and looking at how that has changed over time. We're going to be using linkage, the technique that we saw in the capitalism and democracy lectures, to try to see whether particular words appear in articles that mention single mothers at a greater frequency than we would expect by chance, knowing the proportion of articles that mention single mothers and the proportion of articles that mention some particular term. So the goal here is kind of to show you what programming in Python looks like, and to do that with a problem that is interesting or maybe useful to you as FAHA students. So this notebook is going to be available to you. It will have the outputs pre-run, which means that you can just open it up in a browser and look at exactly what I am looking at. But if you want to run it, you're going to have to install Python and Jupyter. So the first thing that I do in this script is I'm going to load some Python packages, which we call libraries. And these are pieces of script. They're more than just individual scripts. They're sets of scripts that allow us to easily do something in Python. So instead of writing all the code ourselves, we're going to use code that other people have written that is stored in a place that Python knows about. And the way we do that is through this import structure. So we say import, and then we say the name of a library. There are two kinds of libraries. There's standard libraries, which are libraries that have been integrated into standard Python. So when you install Python, it comes with those libraries already. And then there's kind of user written packages, which are you have to install on your own. And there are two basic ways that we install in Python. One is, and I'm actually just going to type in here. So let's see. This package pandas is the package for loading data that looks like a spreadsheet. And it allows us to do things to that spreadsheet very quickly and efficiently, like find values or transform the data, much the way that we would in Excel. And this is not a standard library, but it's a library that many millions of people are using. So it's a very widely used library. And to install pandas in regular Python without conda, we would type into the terminal pip install pandas and then hit enter. And in conda, we're going to do basically the same thing, except we're going to tell conda to install pandas, and then it will ask us some questions. We say yes, and then it will install that software. And then when we want to use it, we just write import and then the name of the library. And some of these constructs are a little different. This from says from this particular library, get me these things. I'm not going to tell you exactly what those things are because we need to go slowly. Or I can say import this library as this, and I'm going to refer to pandas with PD, this PD variable, which is also standard. And I have here, you can see a lot of comments. So comments in Python, we do the hash mark or the pound sign, and then I can write to you or to myself to explain what I'm doing. And you can see that that VS Code is doing some highlighting. So the thing that's really clear is that the comments are in this a little slightly yellow-green. And then in this pink, we have kind of standard Python structures. And then in this blue-green, we have variables. Actually, I guess that's specifically libraries. So I'm just going to talk to you a little bit about the project before we get into the code a bit more. The idea that we had was to look at the association of single mothers or single motherhood and terms that we thought were related to particular aspects or framings of single motherhood. And in order to do that, we kind of are ad hoc defining what those words that we find interesting are. And there's a couple of reasons that we want to do this. One is that we don't want to take a lot of time to come up with some method to find the words for us. Maybe we also think that we can do a better job as smart, intuitive human beings who know something about what we're studying. But also, the way that the New York Times API is set up, we don't have access to the full text. So we can't actually mine the full text for terms. We can only say, show me all the articles that have this term and this term. Or in this case, we're going to be saying, just get me the counts of all the articles that have this term and this term. So what we did was we just started looking at the New York Times and finding articles that mention single mothers. And then we found some kind of type articles that we thought were representative of particular perspectives on single motherhood, and then did a close reading and extracted terms that felt meaningful in this discourse around single mothers. And so, very crudely, we can say that we have a category of positive portrayals of single mothers and one with negative portrayals. And I have both of the, I use two type articles for each the positive and negative categories. And they are listed here, so you can read them yourself. Just a brief summary. The positive articles tended to portray single mothers as educated, white, and single by choice, and that they do encounter struggles, but the struggles are manageable. The negative articles associated single mothers with low education, poverty, and welfare, and they didn't specifically say that those mothers were non-white, but it was implied at certain points. So I will also say one of the things that you do when you're constructing these lexicons, which people often refer to as dictionaries, which I find kind of confusing because there's no definitions associated with the terms. It's really just terms. I'm not really sure why that term came into being. Dictionary. Lexicon seems to me a much clearer description. So as I was reading and pulling out words that felt really meaningful, some themes started to emerge, which I call topics, and groupings of these words. And so I kind of pulled out a lot of words that I thought were meaningful, and then I organized them into these topics. And then I noticed that certain words were missing, words that I thought were connected to those topics, but just didn't happen to appear in the particular articles. And I came up with, this is kind of after it's been organized and edited a fair amount, but let's see, we have 4 topics here, 2 topics here, 4 topics here. And these are broadly grouped into these categories of positive, neutral, and negative. And kind of as I went on, I realized that I didn't actually need this many words. There's a lot of redundancy. It's hard to interpret analyses for so many words. And I was able to narrow these topics down to words that I thought were more representative of kind of both kind of the diversity and some of the redundancy within the topics, and also were more limited to words that were used very frequently, because words that are used infrequently are not very useful to us. I left this here to kind of show my work. You're not seeing the really sketchy stage of pulling out all the words. You're seeing it in a state that's fairly organized. But here I ended up narrowing down my topics to a smaller set of terms. And I actually ended up, in the process of narrowing them down, coming up with refining the topics and adding some new ones that I thought would be good to look at, but didn't come out in the original set of topics. So they're here in these abbreviated topics, and I also have some terms that I'm going to be looking up so that we can do our both get a sense of kind of what the history of the use of single motherhood is, and also that we can do our linkage calculations. So this all articles topic includes an empty space string. So this, in quotes, we have strings, which is text data in Python. It's a data type that holds text. And when we query the New York Times API for this empty space, it gives us the count of all articles. Just briefly, a little bit about Python. This structure is called a dictionary. And a dictionary is denoted by these curly braces. And dictionaries are a sequence of two things. They're a sequence of key value pairs. So each line here has a key value pair, which is actually the pairs are defined by this colon and then a comma. So key, colon, value, comma, and then I move on to the next one, and they don't have to be on separate lines. This structure in the square brackets is a Python list, which in a lot of other languages is called an array, and that's just an ordered sequence. And Python is very flexible, and you can basically put anything you want in any data type in this Python list, and you can even mix them in the same one. So it's important to know that you have a sequence and the order matters. It's going to remember the order. And I should also say that Python dictionaries in other languages are called hash tables, usually. Okay, so I'm going to show you some of the functions that we are going to be using to do this analysis. These are functions that I wrote to perform particular tasks. And you can think of a function as kind of like a little machine that takes a set of inputs and then reliably performs some operations over them and then gives you an output. So the way we define a function in Python is through this def structure. And then we say, this is the name of my function. And then in parentheses, we say, these are the inputs that we are expecting. And then we can use these inputs inside the function. So let's not look at this flattened function because it's a little confusing. Let's look at this construct New York Times API query function. So it takes 3 inputs, a set of terms, a start year, and an end year. And what we're going to be doing, I should also just say, the reason that you see this equals 2000 here is because these are the default values. So we're saying by default, we're going to look at the year 2000. But we can also, when we're calling this function, we can tell it what year we want instead of the year 2000. So we're going to be communicating with the New York Times application program interface, which basically is, we send a URL to, well, we go to this URL, and then there is a program on the other side that looks at that URL, parses it, fetches the data that we're looking for based on the request that we're making, and then gives us back some HTML that contains the answer to our query. So we are going to be constructing a string, which is that URL, and we're inserting into that URL. So here we see the start. We're going to newyorktimes.com, and we're saying we're making a search, and we can ignore that. And in between these ampersands, we have the different parameters to our query. So the end date is our year and 12/31, and then we have our query, which is the terms that we're looking for, and then we have our start date, which is another year, the start year, and 0101, and we're only going to be looking at articles. And then it hands us back this function. We call the function, and then it hands us back this string called URL. We stored it in a variable called URL. And the way we send it back is using this return structure. So let's look at another function. This is this scrape and parse New York Times. So we give it a URL, and then we use this requests library from Python to ask, on the web using HTTP, ask for New York Times to send us the data corresponding to this URL. And we're going to store that HTML in this thing called response. So here we have an if statement. So we're saying if this response has a status code that is equal to 200, there was a failure, show us that there was some error. And then what we do here, I'm not going to go into it, though I do have some comments explaining what I'm doing, is we take that HTML and we're going to look inside that HTML for a particular HTML tag that stores the information. So when we make the request on the New York Times API, and you can do this yourself, I'm not going to do it, but you can copy this and put in your own information here. It will give us this HTML that says, actually, you know what? Let me open up my screen sharing, and I'm actually going to show this to you. I'm back, and I'm ready to show the New York Times search API in the browser. So I'm going to start by describing this function again. So we have a function here, scrape and parse New York Times, and it takes the URL that we constructed up here using our construct New York Times API query function. And what this function is going to do is it's going to use this request library. This is a standard library in Python that takes this URL, sends it across the internet using HTTP, and then returns to us the HTML that we would see in the browser. So the browser is just reading the text that is sent to it over the web and displays it in a particular way. And this response is just a string holding that HTML. Here we have this if statement that looks like if condition. So this is the condition, and then colon. So if the response has a status code that is not equal to 200, which is success, we know we have a failure, and we just want it to tell us what happened. So this is kind of debugging. There's something wrong. We want to know whether there's what is wrong. But what exactly are we going to do once we have this HTML? So instead of showing you the text that is stored in this response, I'm actually just going to go to the browser, and I'm going to show you what the HTML looks like. So I'm going to search the New York Times for single mother, and the date range is going to be all time. And we can see right here, it's kind of tiny, but it says showing 6,505 results for single mother. So there are 6,500 articles in the history of the New York Times that have contained the phrase single mother. And the code that I've written uses this HTML to get this number. Basically, what we want to do is for each year, for each term, or pair of terms, we want to know how many articles there have been. So we can say, well, let's do it like the script does it. By default, it does the year 2000 and the whole year. So in the year 2000, we have 197 articles containing single mother. And we can see up here that this URL looks just like the ones that we're constructing using our function. If we want to know single mother and soccer, 5 articles. Okay. So now I'm going to go back to Visual Studio Code. And this little block of code, I'm not going to walk you through it, though there are comments if you're interested in what's going on, basically is just doing what we did visually in the text. It's finding that little block, pulling out the number, and removing the comma and converting it to an integer instead of a string. And then this function returns to us the count. And then we have here a function that takes a set of terms. So that would be, in this case, we're doing 1 or 2 terms, a start year and end year. We're saying give it to us in years, what single year intervals, but we could say give it to us in 5-year intervals. And then we can ignore these other variables. And then we have this for loop, which is going to say for each of our years from start year to end year, get that URL, give us the count, and then we're going to store it. There's a lot more going on here. I've written comments that you can read yourself, but I'm going to let everyone do that at their own leisure because it will take a long time for me to explain what's going on, and it will get in the way of actually talking about the analysis. So here, we're actually going to construct all of those URL queries and then scrape those numbers and store them in a dictionary. And it's actually going to be a dictionary of dictionaries. So the outer dictionary, the keys are going to be the particular terms we're using, and the inner dictionary is going to be a year and then the count. And what we're going to do is we're going to save, actually, as we're going, because this takes a long time, we're going to save those counts in the dictionary, or we're going to save those dictionaries of counts as a Python pickle file, which is just a way that you can take this, the information that Python is storing, and save it in a way that we can reopen it later. So at each step, after it mines a term, it's going to save this dictionary so that we don't have to do it again. And now I'm just going to run this script, or actually this code block, by pressing Shift Enter, but I could also press run by line and just run that code. And we see some output. So it says scraping counts for, this is the empty space, and it tells us that it found about 5 million articles. And then it does single mother, and we have 6,376. That number is different from what we saw, just because we're only asking for articles instead of like videos and graphics. It does that for unwed mother and so on and so forth for all of the terms. And this is going really fast because it's actually just loading up this dictionary and checking to see that all those counts exist. And then it's reporting to us the count instead of doing it from scratch. And I'm going to provide these Python pickle files for you so you don't have to wait. It's been a while since I've done this, but I believe it takes about 6 hours to scrape all of these terms and years. So we do that for all of the individual terms, and then we're going to do it for all of the pairs of terms. So it's single mother and all of those individual terms. So that allows us to get the joint probability of single mother and a particular term such that we can compute linkage. Now we're going to make some very basic plots that give us a sense of what is going on in our data. These are some functions that are going to help us make nice plots. And then this is a little ugly. I didn't write I didn't write a function to make these individual plots. So the first question that we're going to ask is how many articles were published each year in the New York Times? And then we're going to visualize it to answer that question. And then we're going to ask how many articles were published containing the term single mother and unwed mother. Then we're going to ask what is the probability an article contains the term single mother and contains the term unwed mother. And then we're going to do this same plot, but we're going to use some different terms. Some of the terms that are included in our dictionary or lexicon. So I'm going to, again, press Shift Return, and it spits out some plots. So here's that first plot. The number of articles published in the New York Times by year. We can see that, and this is from 1970 on, that it's staying fairly stable around 100,000. And then in the mid 90s, so this is when the internet starts to really take off, the number of articles increases, and then it sharply decreases. And it'd be interesting to know why exactly that's happening. Part of it is probably because there are new kinds of content that are being produced that we're not capturing, those graphics and videos, but I'm not entirely sure what accounts for this pattern. I mean, we do know that newspapers are struggling, so that could be part of it. It is part of it. Now we're going to look at the number of articles with particular terms by year. And we can see that the peak for single mother happens just before, it looks like, this peak for all articles, but that it starts off very low in the 1970s, starts to kind of take off in the 80s and 90s, and then it looks like it kind of flatlines despite this downward trend in the total number of articles. We're also going to look at unwed mother, which is an older term. And we see that it starts off higher than single mother, kind of stays around there, and then it looks like it kind of decreases until it's not used at all. Now we're going to make this plot again, but we're going to do the probability that an article contains this term. So it's this line over this line and this line over this line. And we see that, this trend of more articles about single mothers in the 80s and 90s is still here, but instead of flatlining, it's going to increase because the total number of articles has decreased. And this line is hard to read, but it basically looks the same because it's just so low. Okay, so now we have a set of terms related to poverty and welfare, and we can see the probability that an article in the New York Times mentions these terms. So the top line, this orange line, is poor, and not surprisingly, that is the highest probability. It looks like it tops off at about 7% of all articles, and that's not surprising because poor has lots of different meanings. Whereas poverty has one specific meaning, that's this blue line here, and looks like it's around 1% of all articles, going up to 2 in the aughts, and then it seems like it is increasing over the past decade. And maybe that is because the New York Times has a greater interest in poverty and inequality. We don't really know. Welfare starts off fairly high, around 3.5%, dips down. Then in the mid 90s in the US, there's a lot of debate around welfare and what its function is. And it seems like that is like a blip kind of during the Clinton presidency, and then it goes down to the level that it was in the 1980s. and it seems like it mostly stays there. And then we have public assistance, which is a euphemism for welfare, social welfare, and it's really kind of hard to see what's going on because it's just so low. We can't really visualize much in this plot, though we can see it looks like there is a corresponding spike here, but it's a very small spike. Okay. Now we have some functions for computing linkage. I'm not going to walk you through these. I'm going to run this, and then we're going to make some linkage plots. So this is what we came here for. We're going to visualize the linkage between single mother and all of these terms in our lexicon. And we're going to do it by topic so that similar terms are going to be visualized in the same plot. So here we go. I'm going to run. Oh, wrong one. Okay, spitting out a bunch of plots. So let's go up to the top. And we see the linkage of single mother and terms for women being educated, women having education. In all of these plots, so I have 3 different versions of this plot. The first one is the raw data, which you can see is very, very spiky. The second one, I smooth it by doing a 5-year average. So we're no longer looking at individual points. We're looking at the average of 5 points, and we're just going to keep sliding that window along. So we have almost the same number of time points, except for the ones that we couldn't make a full window for. And but each of those is going to have a 5-year average, which gives us a much smoother line, and is kind of smoothing over a lot of that noise. But if you remember in the beginning of the window that we're looking at, 1970 to today, there are very few articles for single mother. And so we're likely to get joint probabilities that are very, very high, artificially high, just because there's so few articles. And so this 1970 and 1980, I don't think is very trustworthy. So when we're looking at those numbers, to me, it's hard to really make a judgment because we have so little data. But the pattern the patterns in 1980 to today are much more robust because we do have a larger number of articles starting around 1980. So we're gonna ignore this 1970 and 1980 when we're talking about the plots, or when I'm talking about the plots. And then this last plot, I transform the axis so that it is in log scale. So I visualized linkage of 1 here using this dotted line. 10 to the 0th is 1, 10 to the 1st is 10. But we're no longer on a linear scale. So what it has the effect of, I'm trying to think of a way to explain this that is easily digested. It has the effect of making big differences much smaller so that we can see little differences more easily across the whole scale of numbers. And so what we see is that linkage, we can look at either of these plots to see this, but it's easier to see the downward trend in these areas where linkage is low, that there is a downward trend. So starting in 1980, linkage is higher for all of these terms and then kind of steadily decreases. And we can see that middle class and educated track fairly closely with one another. And that professional and independent are at lower frequency, but also have this downward trend. I have to charge my computer. So we can scroll down and we can look now at these terms for choice. The idea being that the virtuous single mother is the one who chooses to become a single mother, as opposed to somebody who finds herself unwillingly or by surprise in the condition of single motherhood. So this is the positive portrayal of single motherhood. And we see a very similar pattern. You notice that for educated, linkage is generally higher for these educated terms and single mother than it is for choice, which is not surprising. Again, these words for choice are very general, and so are going to appear in lots of contexts. But it is higher than we would expect by chance. And these orange and blue have the higher linkage. These are choice and choose, and they track very closely. And decision and possible also seem to track very closely. And again, we have this consistent trend of starting off higher and then declining over time fairly steadily. I'm not going to talk about these choosing a child terms. We have single mother and paying for assistance. So this idea that the single mother is a professional woman who works during the day and can afford childcare. You can see that childcare terms are very closely connected to single mother, not surprisingly. And again, these two terms are childcare and sitter are very closely connected and start off high, end up still very high, but again, have this pretty consistent downward trend. Now we're going to look at our neutral terms. So we have a set of terms related to support. And again, everything, all the linkage is greater than 1, starts off high and steadily declines. The same for these terms related to the struggle of being a single mother. These seem to decline less steeply than the others, but there is, again, this pattern of starting off high and declining. Same for welfare and public assistance, which unsurprisingly, linkage is very, very high. There's a lot of conversation around, in particular, beginning in the 80s and 90s, whether social welfare encourages single motherhood. And then we have a set of terms for race. And this actually is, here we can see a pattern that deviates from this pattern of starting off high and then declining. White and black, we see are closely, really closely track one another and decline somewhat, but maybe not all that much. I really can't account for what's happening in African American. It starts to be used in the New York Times around 1985, where we'll actually see this in a different plot later on. It seems to me that maybe in the beginning this is somewhat unreliable, but that it probably does increase somewhat and then declines very rapidly in the past decade. These are terms, so now we're in the negative terms. These are terms for single mother and poor character. You can see that, in this early time period where we don't have a lot of articles for single mother, linkage is extraordinarily high for promiscuous in particular, promiscuous and promiscuity. And that's also because those words appear very, very rarely in the New York Times. And so you have a very small number of single mother articles and a very small number of promiscuous articles. When they do appear together, which they do, linkage is going to be very, very, very high. Here we don't seem to have this pattern of decline. Maybe slightly for promiscuous. Actually, it looks like it does drop off at the end. But these look flatter than what we've been seeing. I have a set of terms for social ills. Again, those start off high and then tend to decline. Same with poor parenting. Though it looks like maybe it starts to decline earlier than the others. And then we have a set of terms related to being uneducated rather than educated. And here again, we have this pattern of decline, though again, linkage is very, very high for these terms. So the general pattern that we think we're seeing here is that in the beginning of when is this discourse about single motherhood, kind of in the 70s, but really starting in the 80s and 90s, it seems like there's a lot of discourse around what single motherhood is and whether it is virtuous or not, and whether it should be encouraged or discouraged, and how that plays into poverty and welfare. And that is precisely what our type articles are about, which are taken from the late 80s and early 90s. But over time, we think what is happening is we get less of these articles about what is single motherhood, and single mother gets kind of is no longer a thing that we are discussing to figure out what it is. It's just something that we talk about. It just kind of gets assimilated into the discourse, and people are no longer arguing over what it is. They're just talking about single mothers in everyday life. There are, of course, still articles that are doing the same things, but they're happening at much lower frequencies. We don't need to explain what a single mother is or debate what a single mother is. We can just invoke one in conversation. And that's why we think we're seeing linkage decreasing, particularly in the aughts and 2010s. So, for me, there isn't a really exciting story that comes out of this. I think we were hoping to see something like a shift from negative framing to positive framing, as there was a shift in the 80s and 90s that has continued today in the US towards single motherhood across all races and social classes. Single motherhood has become increasingly common. It has become the increase in single motherhood has, though, been sharper among white women and educated women in particular. And so we were expecting to see a shift in the New York Times reflecting single mothers that look more like I think the person that the New York Times believes is its reader, which is upper middle class or wealthy and white. But that's not really what we see, and that's fine. That's what empirical research is all about. Of course, we could go a lot deeper and do close readings of these articles and see whether this method is really crude and really fast, which is great. It's great to be able to do things really quickly, but often we want to be able to use human minds to do what human minds are so good at, and it happens that linkage is not a good tool for that. We need to just do things the hard way. So before I sign off, I want to show one other set of plots, just because I think it's really interesting, and this kind of came out from our investigation of single motherhood. And so we were just like, well, what about Simon said, we should look at race and single mother, which we did. And again, I think the patterns are kind of hard to interpret. But then, I was just wondering, like, well, what about different words for Black that Black politics, the civil rights movement, over time, there have been cultural shifts where the preferred term has changed. And I was, just interested in looking at that and whether we could learn anything else by looking at these terms. And so I'm not going to walk through what's going on here, but we have 1, 2, 3, 4, 5 terms for Black persons, and a control, sort of, looking at the word white. And what we see is, so for those of you who are familiar with American history, there's a lot of stuff here that is not surprising. So I have kind of lined up these terms in order of historical use. It's also, we know that a lot of these terms have meanings that just pertain to color and not to race. So we're going to see that too. So what we see is that Negro starts off not very high, but it's the highest of the terms that are being used. More, well, it's hard to know what exactly is going on with colored. And then when the civil rights movement starts really to take off in the mid 1950s, we see references to Negro take off. And that's not because the term is becoming favored, it's because the New York Times is more interested in Black politics, because that's what's going on in the country. And I think the coolest thing that we see here is that white and Black look like they are fairly stable. There's a lot of noise, but they look fairly stable for the history of the New York Times, the 100-year history prior to the civil rights movement. But something happens around 1955. Actually, wait, that's not quite right. Here it would be 1955. So around 1960, where the meaning of Black changes, and Black now refers to a social category, whereas before it only referred to a color. And then tracks very closely with Negro. And then there is a change in the preferred term in the late 60s, where Black becomes the term that we're going to use, and we stop using Negro. And you can just see that there's very clearly this, stark drop off for Negro, and Black continues to grow. So Black politics continue to be socially relevant in the New York Times. But then this really interesting thing happens, which is that we can see that the meaning of white has also changed. It's, again, it's no longer referring to the color, or it's referring to the color and something else. And we know this because it's now tracking very closely. Black and white are tracking very closely with one another. And so we can see that when the meaning of Black changes, so does the meaning of white. And, there's some other stuff going on that you can look at yourself. But this, to me, is the most interesting thing, is that we can see very clearly when Black becomes the preferred term, and how when Black becomes the preferred term, the meaning of white is also changing. And we can see this if we do the linkage plots for Black and white. What we see is that when the meaning of Black changes, these terms which were not tracking with one another, all of a sudden are tracking very closely, both in the actual linkage and in the trends. For me, these linkage plots are a little bit hard to interpret and not nearly as interesting as what's going on here, but it's really clear that at this moment, the meaning of Black and white are changing. And we can see that because these linkages, which were not correlated, all of a sudden become really tightly coupled to one another. So I'm just going to leave you with that. There is a lot of stuff I think that you can explore by looking at these plots that we didn't talk about, and looking at the code to kind of see what programming actually looks like. You can change the code so that you're using your own set of terms. You can replicate this analysis for a different set of terms if you get Python running on your machine, which I think can be a really useful exercise in learning how to program, more so than I think that this is a really useful tool for doing analysis. I think it could be, but for most of you, it will be much more useful as a learning tool than as an analysis tool.